Today we are starting a new objective, objective 3.3, similar triangle theorems. Today's objective is that you can use similarity theorems and postulates to solve for missing measurements. So before we dive into similarity, let's review some terms that you should already be familiar with, but maybe you're not. But let's look at them. So the first term is ratio, which is basically a comparison between two quantities. And if we have a ratio of A to B and B cannot be 0, we could write the ratio as A colon B or A over B. So like a fraction, you might see it vertically or sideways like this. Those are the same thing. These are all a ratio of A to B. Now a proportion, our definition of a proportion is an equation that states that two ratios are equal. So now we've defined those, let's go ahead and start using them. So we are solving proportions using cross products. So we have to cross multiply in order to solve for variables. So if we see here, we have 3 over 5 equals x over 75. Now let's cross multiply. So we're going to do 3 times 75 equals x times 5, or 5 times x, either or. Now multiply, so 3 times 75 is 225, and 5 times x is 5x. Now divide both sides by 5, we get 45 equals x, and we are done. Now for example B, this one does have an expression instead of just a simple variable, but we do the exact same thing. So cross multiply, we get 2 times 3x minus 5 equals 4 times negative 13. I'm going to distribute this 2, so we get 2 times 3x plus 2 times negative 5 equals 4 times negative 13 is negative 52. 2 times 3x is 6x. 2 times negative 5 is negative 10 equals negative 52. Now I'm going to add 10 to both sides. So we get 6x equals negative 42. Divide both sides by 6. We get x equals negative 7. And we are done with that one. Okay. Now for this bottom problem, we are trying to find the error. Madeline and Suki are solving the proportion 15 divided by x equals 3 divided by 4. Take a second to think which one you might think is correct. And if you said Suki, you would be correct. So remember, we are cross multiplying, so that gives us 15 times 4 equals 3 times x, which gives us 60 equals 3x. And as we see, that's what Suki is doing. What Madeline did was she did not cross multiply. Instead, she just multiplied straight across. So 15 times 3 equals 4 times x, which is not correct. So make sure you multiply numerator by denominator, numerator by denominator, to solve a proportion problem. Let's go ahead and look at the next page. So now we are going to be taking these concepts of proportionality and applying them to similar figures. So similar polygons are figures that have the same angles, but they may be a different size. So I've gone ahead and made two figures here. Notice that they're the same shape and they have the same angles. But this left one is smaller and this one is bigger. Because they're not the same size, that but they do have the same angles and general shape and all, that means they are similar instead of congruent. So two polygons are similar if and only if their corresponding angles are congruent and the measure of their corresponding sides are proportional. And the symbol we use to say two figures are similar is a little tilde like this. So now let's look at an example of our notation. So you want to pay attention to the order of the vertices in a similarity statement. This helps you identify corresponding angles and the corresponding sides. So over here we have two similar figures, and as we can see, they're in the same orientation. So A and E are the corresponding angles. And then we can go like this, so counterclockwise. So figure ABCD is similar to figure EFGH. And this helps us figure out our congruent angles. So A and E, those are both the first vertice. So those two angles are congruent. Angle B and angle F are also congruent. Angles C and G are also congruent. And so are angle D and H. And now for the corresponding sides, it's the same sort of deal. So side AB is our first side. And that is similar to side EF. Side BC is also similar to FG. CD is similar to GH. And DA is similar to HE. So now that we've seen an example of the notation of similar figures, let's look at an example. So now we have triangle NOP over here on the left is similar to triangle QRS. So the similarity statement would be triangle NOP is similar to triangle QRS. We want to find the measure of side SQ, rounding our answer to the nearest tenth if necessary. So first I see we have side NO and side QR. So I'm going to set that up in a ratio. Those two sides correspond to each other, so they are the similar ones. And so since they are similar, we could put them in a ratio like so. Our next set of corresponding sides, or at least the one that corresponds to SQ, is NP over here. So NP corresponds to SQ. So I'm going to set that equal to our ratio of NP over SQ. So this is one pair of corresponding sides, this is another. Now I'm going to plug in my known values. So NO is 17, divide that by QR, which is 57, equals NP, which is 13.3, and I'm going to call SQX. Now we can cross multiply, switch the colors here. So we get 17 times X equals 57 times 13.3. So now ignore this, I meant to take that off. But now we have quadrilateral ABCD is similar to quadrilateral EFGH. We want to find the measurement of side HE. rounding to the nearest tenth. So I see this figure is just figure EFGH is similar to the one on the left. It's just rotated 90 degrees counterclockwise. So I know side AD is going to correspond to side EH, which is our unknown, and that's what we're looking for. I can also see that we are given side CD and its corresponding side GH. So now that I know those two, I can set them up in a ratio. I'm going to do AD over EH equals CD over GH. AD is 37, EH is our unknown X, CD is 26, HG is 7, or GH. Now, cross multiply to solve for X. So we get 37 times 7 equals 26 times X. 37 times 7 gives us 259 equals 26x. Divide both sides by 26. We get, it's about 9.95, which rounds off to 10 for x. And we are done with example 2. Now that we've looked at some algebraic problems, these are all level 1. In order to get level 2, so a C, you have to be able to identify which similarity postulate can help you prove that the two figures, or the two triangles specifically, are similar. So the first similarity postulate is AA or AAA, and A stands for angle. Kind of like our congruence theorems from the last objective. A stands for angle, S stands for side. So when you are given two or more congruent angles in two triangles, then we know the triangles are similar. So for example, over here we are told that P and T are congruent. And Q and S are congruent. If you're given the angles, two pairs of congruent angles, then we know the triangles are congruent. And you only need two angles because you can easily find a third using the angle sum theorem. So two angles is enough to prove they are similar. Now this third one is SSS, or side-side-side similarity. So if the measures of the corresponding side pairs are proportional, then the triangles are similar. So like if side A or side PQ is proportional to TS, side QR is similar to side SU, and side RP is similar to UT. Then we know that the triangles have to be similar. And this would mean that the ratio between each side. So you might also see this as like PQ over TS is equal to QR over SU is equal to RP over UT. That also holds true. If you're given any of these pieces of information, you know the triangles are similar. Or all of these information pieces. The last similarity postulate we're going to look at is SAS, or side angle side similarity. So if the measures of sides are proportional to the measures of corresponding sides, in another triangle, and the included angles are congruent, then the triangles are similar. So in this example here, we have PQ is similar to TS. Angle Q is congruent with angle S. And side QR is similar to side SU. That is enough information to prove the triangles are similar. Now let's go ahead and look at some examples. So for this one, we want to determine if triangle OPQ and triangle RST are similar or not. And if they are, state how we know. So in addition to level 1, if you want to get a C, you have to be able to say the similarity postulate. So we're going to take our corresponding sides. So I'm going to assume the smallest sides are the corresponding ones. So OP is similar to SR. And then I'm going to set that up in a ratio. Okay, so OP over SR might equal, the next biggest side is OQ and RT. So 12, or oopsies, OQ over RT. And these are all we're trying to figure out. And the last one is QP, might be similar to ST. And I miswrote that. That's supposed to be a question mark, not a congruent symbol. So now let's plug in our numbers. OP is 9 over SR is 36 equals OQ is 12 over RT is 48 equals OP, or QP, I mean, which is 14. And ST is 56. So now we're going to divide each of these. I know 9 over 36 is 0.25. 12 over 48 is also 0.25. And 14 over 56 is 0.25. Since all three of these are equal, 0.25 equals 0.25, which also equals 0.25, then we know that the triangles are similar. So yes, because of the side theorem, we're given all three sides for both triangles, and each side has a corresponding side on the other triangle. So we can use the side theorem. Now over here for example 4, we want to determine again if triangle QRS and triangle TUV are not similar. And if they are, state how we know. So I see here we have angle R is congruent with angle U. So those are two corresponding angles. And then angle Q is congruent with angle T over here. Oh, that's two angles, so we know that's enough information to say the triangles are congruent, or similar, I mean, because of the angle-angle theorem. And if you wanted to find that third angle, remember your angle sum theorem. So 180 minus 75 minus 50 equals 55 degrees. So our third angle is 55 degrees. And that's something from term 1. And we are done with that. Now for examples 5 and 6, we need to learn a new theorem, and that is the triangle mid-segment theorem. So before we read the question, we are going to bounce down over here and create a little note box. So let's say we have some triangle ABC, and we give it a mid-segment. Oops. And we're calling the mid-segment DE. So if DE is a mid-segment, which means it splits both of these two sides in half. So if segment DE is a mid-segment of triangle ABC, and the segments DE and BC are parallel, so this side and this side, or both those segments are parallel, then we know segment DE is equal to 1/2 of segment BC. Or the converse of that, segment BC is equal to 2 times segment DE. So basically this bottom segment is twice the length of the mid-segment. And that is the triangle mid-segment theorem. Okay. Now let's go ahead and bounce back to our question. So in the diagram below of triangle EFG, we know H is the midpoint of EG and I is the midpoint of FG. That means this is a mid-segment. GH and HE are going to be congruent, and GI and IF are going to be congruent. And HI is going to be half of EF. So that is what this first sentence tells us. We know HI is equal to negative 3x plus 14, and EF equals 15 plus 7x. Okay. And I'm actually going to use the other way around because I don't like dealing with fractions. So I know EF, which is our longer segment, is going to be twice the segment HI. So now I'm going to get started. So EF equals 2 times HI. So if EF is 15 plus 7x, that is equal to 2 times HI, which is negative 3x plus 14. Okay. Now we can solve for x. So I'm going to distribute this 2. So we get 15 plus 7x equals 2 times negative 3x plus 2 times positive 14, which gives us 15 plus 7x equals 2 times negative 3x is negative 6x. 2 times 14 is 28. Now I'm going to add 6x to both sides. That gives us 15 plus 13x equals 28. Now I'm going to subtract 15 from both sides. That gives us 13x equals 13. Divide both sides by 13. We get x equals 1. Now we're not done yet because we want to find what EF equals. So remember, EF equals 15 plus 7x. That was given to us in the problem. So I'm going to plug in my 1 for x. So we get 15 plus 7 times 1, which is the same as 15 plus 7, which is equal to 22. So EF is equal to 22 units across. Now for this problem here, we have another little bit to the triangle mid-segment theorem. Pew, 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 pew. So another thing that the theorem tells us is that angle A is going to be congruent with angle A. So this top angle is congruent to itself. Now angles E and C, those are corresponding angles. So I'm going to call that angle ADE. No, AED, my bad. Just to specify, we're talking about this angle here. That is congruent to angle ACB. And angle ADE is congruent with angle ABC. So that's another piece of information to keep in mind with the triangle mid-segment theorem. Okay? So now here, in the diagram below of triangle MNO, we are given that P is the midpoint of MO and Q is the midpoint of NO. So this is a mid-segment. The measure of angle OMN, which is this one right here, is negative 42 plus 8x. And OPQ is 9x minus 50. What is the measure of angle OMN? Well, we know those angles are congruent, so we can set them equal to each other. So angle OMN is equal to OPQ. So we're going to take both of those expressions and set them equal to each other. Negative 42 plus 8x equals 9x minus 50. Okay. Now I'm going to subtract 8x from both sides. That gives us negative 42 equals x minus 50. Add 50 to both sides. We get 8 equals x. Now we're looking for the measure of angle OMN, although you could really use either of the expressions because they are congruent. But let's just work with OMN because that's what it tells us. Angle OMN is equal to negative 42 plus 8x. So I'm going to take negative 42, add that to 8 times 8 because x is equal to 8. That gives us negative 42 plus 64, which is equal to 22 degrees. So angle OMN is equal to 22 degrees. And that is all I have time for to record. I'll do example 7 and 8 in a separate video. But if you have any questions, just let me know. Have a wonderful day. Bye!